Experiment laser diode. See, we have a laser diode. It is a two-terminal semiconductor device. This laser diode acts as incoherent source and coherent source. We are finding threshold voltage in the experiment. Threshold voltage means what is the minimum voltage required. It changes incoherent source into coherent source. The difference between incoherent source and coherent source. Incoherent source have a different phase and coherent source have a same phase. It acts as both. We will find threshold voltage in the experiment. Experiment instrument, laser diode, potentiometer, battery switch, 9-volt battery, breadboard, photodiode. And this laser diode we will connect to the two terminal pin. See this line. These two terminal pins will connect to the potentiometer. How to connect two terminal pins to the potentiometer? See, this laser diode will connect to the potentiometer two terminal pin. This line. Multimeter circuit diagram in the experiment. Potentiometer part. Potentiometers have 3 terminals, 1, 2, 3, and 9-volt battery, and output photodiode, and input laser diode, and you are measuring output voltage in the photodiode. In the experiment, potentiometer 3 terminals, first terminal positive power supply and second terminal negative or grounded to the power supply and output. Negative or grounded is both common for input and output, the second terminal. We soldered 100 ohm on resistor because the laser diode is a 5 volt operating voltage. Battery is 9 volt. If we soldered first terminal to the 100 ohm resistor, it limits the supplied voltage. We are supplying input voltage to the potentiometer. Using the potentiometer knob, we are setting the required voltage in the experiment. And the required voltage, it goes to the output terminals, terminal number 3 and 2, to the laser diode. The laser diode light is falls on the photodiode. The function of the photodiode, when a light is falls on the photodiode, it converts light energy into electrical energy. That electrical energy you are measuring in the output terminals, photodiode wire, positive and negative. This negative terminal is common for same both input and output. In 9-volt battery, we will check residual voltage in the battery. This battery is 9 volt. In the multimeter DC, we will keep DC 20 volt range and check positive and negative. Positive terminal, negative terminal. Near DC circuit or DC power supply, we will keep positive to positive, negative to negative. The power supply, the battery voltage is 8.75, the residual voltage. This battery is good for in this experiment. You will select more than 7.5 or 7 residual voltage in the experiment, because some batteries are drained. Don't use drained batteries in the experiment. Laser diode. Laser diode two terminals pin will connect to the potentiometer output two terminals. And this laser diode will fix it to the movable guide. Yeah, will fix this side. And take 9-volt battery. 9-volt battery you are connecting to the potentiometer switch. And take photodiode two terminal pin. See, in the photodiode length one is positive, short one is negative. Here we will connect positive to positive pin and negative to negative. This wire is positive and black wire is negative. We will connect positive to positive, negative to negative. And this photodiode output will connect to the fixed guide. And take breadboard circuit connection. Laser diode junction voltage wire positive, we will connect here, and laser diode negative wire will connect separate, and take photodiode output wire positive will connecting separate, and negative photodiode wire is common or grounded to the negative input of the wire. Negative input and positive negative input and negative output, both wires are common, we connected grounded here. And now you are measuring the input voltage in the multimeter. You will keep range in the 20. First voltage you will check laser diode positive to positive, and a negative wire connected to the negative or grounded. And now it will show 2.23 input voltage. Now we will set input voltage using the potentiometer. Now rotate the potentiometer. Now we start from experiment 1.5 input voltage. Behind the 1.5 light is not glowing, that's why we will start from 1.5. Keep 1.5. We set it 1.5 using the potentiometer knob, and we fixed the two guides in a certain distance and adjust the light, laser light make falls on the photodiode. You can keep some distance here and adjust the light. So now we fixed the input voltage 1.5. In this input voltage we are measuring the photodiode voltage, output voltage. We are using same multimeter. Disconnect the laser diode positive wire multimeter, and same multimeter positive wire we will connect to the photodiode or output wire positive. It will shows the photodiode voltage. Photodiode voltage output, it will shows very small voltage, that's why we are measuring in the range of 2. See, now in the range of 1.5 the output photodiode voltage is 0.030. Tabulate the output voltage. After tabulating, once again we will changing the input voltage using the laser diode wire. Disconnect in the photodiode, same wire multimeter will connect to the positive power supply or positive power supply of the laser diode. So next range we will keep in the 20. Using the potentiometer knob we will change another voltage 2. We set it input voltage is 2. In this input voltage check the output voltage, and once again ensure that the laser light is falls on the photodiode or it's going outside. You can check if it is going outside, adjust the beam of the light, make falls on the photodiode, and disconnect the laser diode multimeter positive wire. Positive output of the laser diode. Check the output voltage in the range of 2. See, now it increases 0.034. Similarly, you can do the different trials. Input voltage you can change 0.2 increment or 0.4 increment till 4.2 or 4.4. Using this output voltage and input voltage, we are plotting the graph. Tabular column, laser diode voltage you are changing 0.2 increment or 0.4 increment, and you are tabulating photodiode voltage in a photodiode output voltage, and using this laser diode input voltage and output voltage we are plotting the graph. Photodiode voltage is in y axis, laser diode voltage is in x axis, Vi input voltage, and our obtained graph is just like, see here. See, the graph is the output voltage is suddenly jumps and it goes to straight line, and behind the straight line the curve is flat. So in the straight line graph you are taking tangent line. The tangent line intersecting x axis point is the threshold voltage in the experiment. The threshold voltage is changing the character incoherent source into coherent source. The laser diode switch over coherent into incoherent. That is the result in the experiment VTH. You are finding using the intersecting x axis point. In this experiment you are finding diverging angle in the second part. Diverging angles means is the angle at which a light beam spreads out as it travels away from the source. Light beam do not remains perfectly parallel, they expand. The expansion or spreading is measured as the divergence angle. Laser have small divergence, but LEDs and incurrent source have large divergence. Laser diode have a small diverging angle. You are finding in milliradians, 1 to 10, like 1 to 10 milliradians, and LED lights are 10 to 60 degree, very large angles. You are measuring in degrees. In the finding diverging angle of the laser, we will keep maximum light. Yeah, and circuit is not required in the second part. Now change the distance of the laser. Take a graph paper. Yeah, measure the beam diameter in a one distance. Measure the beam diameter. Here it covers 1 centimeter, and change one more distance. In this distance also we are measuring diameter of the beam light. In a two different distance we are measuring two different diameter. We are getting two different diameter. Using the diameter and distance, we are calculating diverging angle d2 minus d1 divided by z2 minus z1. Here d is the diameter and z is the distance. d2 is the diameter 2, d1 is the diameter 1, z2 is the distance 2 and z1 is the distance 1. In a two different diameter and distance we are measuring diverging angle, and it is a very small angle. We can say that very small radians. Result and conclusion in the experiment. The threshold voltage of the given laser diode VTH we are measuring in the experiment, and the angle of the divergence of the beam found to be theta dash radians.